Have you actually thought about how light actually reflects? If we just imagine here three photons are bouncing off, well, the velocity is c, which is the speed of light, and c after, but if it's reflecting, the velocity has to be 0 when it hits the mirror. So the question is, can it? Let's talk about it in this video. Hey guys, it's Iron Anatomy here. Today we're going to be talking about this reflection/light paradox. So the question is, how can light speed be actually 0 when it bounces off something? Because we know that if an object is moving in one direction, and if we want it to move in the other direction, then at some point in time, the velocity or the speed has to be 0. Right over here. It has to be 0. It doesn't matter how fast it's going. You can try it with anything. You could, right now have a ball, put it in your hand, bring it forward, and if you're bringing it back, there's this specific instant in time when the velocity is 0. So how can light have 0 speed if light always has the same speed, which is c? So we know that a photon is actually a bundle of energy. It's like a pocket of energy. We are just interpreting this question wrong. A photon is not like a ball. A photon is energy, so it's like either a wavelength or it could be a particle. Depends. So it could be like a wave, or it could just be a particle moving across space and time. Let's talk about the atom. We know that there's a nucleus and then there's orbitals around it. These orbitals contain the electrons. If you're in high school or you're past high school and you already know about chemistry, you know that electrons are in orbitals around the nucleus. You may or may not know this, but an electron can jump from one orbital to another. In this case, if it wants to jump to an orbital above itself, that means it gained energy from somewhere. So you can see like this gained energy from light, for example, and it jumped up. And the reverse thing can happen. The electron can drop to a lower energy level, so it's more stable, and when it drops into the lower orbital, it releases energy, or a photon, it releases it. Now with that information in mind, you may already know this kind of stuff. We can say that the mirror has electrons. Right? Everything has electrons. The mirror has electrons, and say the atom looks like this. And a photon is going towards it. So remember, photon is like a wave or a particle. In this case, we drew it as a wave. So there's the energy that's going towards the mirror. Now, what will happen? Well, the electron will absorb this energy, and the electron will jump to a higher energy level, just like I said before. Now, instantly right after, since the electron wants to be at the most stable level, it wants to drop back down to its original orbital. And so what it does is it drops, and as it drops, it releases a photon, or it releases a light. And that's how it works. That's how reflection works. It's not like a ball bouncing off a wall where the speed has to be 0 when it hits the wall. It's a completely different story, and this is how basically quantum mechanics and special relativity, that's how this all works. Thank you guys so much for watching.